So here the given problem is a pentagonal pyramid of base side 30 mm and axis length 60 mm is resting on SP and one of its triangular faces with its axis parallel to EP, draw its projections. So here the given problem is a pentagonal pyramid. So pentagonal pyramid is a solid object. It has three dimensions. So pentagonal pyramid means it has one base and one apex, five bases, five slanting edges, five triangular faces, and one axis perpendicular to the base. So here the dimensions of the pentagonal pyramid given us. Base side is 30 mm and height of the pyramid or axis length that is given as 60 mm. This is resting on horizontal plane. So which one is resting on horizontal plane? One of its triangular faces. Totally how many triangular faces? It is a pentagonal pyramid, so five triangular faces. Out of five triangular faces, one of the triangular faces resting on SP in such a way that the axis parallel to VP. So here the axis parallel to VP means that indicates that axis inclined to SP. So based on the given problem, we have identified that axis inclined to SP and parallel to VP. So in the pentagonal pyramid object of given dimension, when it is resting in SP by one of its triangular faces, when axis inclined to SP and parallel to VP means at that time how it will be to the observer in front and top. That is the question. So here, based on the problem, we have identified that it is the axis inclined to HP and parallel to VP problem. So here, once we have identified the axis inclinations, then we have to go for step one. Actually, if the axis of the solid, the type of solid may be anything. If the axis of the solid is inclined to any one of the reference planes, maybe horizontal plane or vertical plane, we have to do two steps for getting the final front and top views. So here we have identified that the given problem is axis inclined direction and parallel to it. It's to one of the reference plane. The given object axis is inclined. So first straight away you can't able to get the true shape of the true projection of the front and top. So first we should know the true shape of the object in front and top so that we can able to project the reduced shape based on the given condition. So for that, step number one, I am assuming that given problem is axis inclined to SP, but I am assuming that axis is not inclined to SP. I am making it into perpendicular to SP in such a way that the base is completely resting on horizontal plane. So at that time, axis parallel to VP. So when base, the object is a pentagonal pyramid, when base is resting in horizontal plane, axis perpendicular to SP and parallel to VP, at that time we have to draw both of the views, top and front. So which way we have to draw first means we have to draw the top. Why we have to draw top view? Because when the base is resting in horizontal plane, the true shape of the base of the pentagonal pyramid will be visible to the observer during the top. So first we have to draw the top view. From the top view, we have to go for the front view. So in step number one, first we have to draw this pentagon. So pentagon has five base sides. So in the top view, along with the base sides, all the slanting edges are visible and apex also visible. So this is the top view. So first I have drawn the top view. Then from all the parameters of the top view, that is the AB, the bottom base corner, A, B, C, D, E, we have to draw vertical projection line until meeting the XY reference line. Then we have to go for the front view. So the base is resting on horizontal plane. So in the front view, the base will come exactly on XY line itself. So from here to here, this is the base of the object, and the base is resting horizontal plane. The next here the height of the pentagonal pyramid given as 60 mm. So to this base perpendicular to the baseline, we have to draw axis line for about 60 mm. Then we have to draw slanting edges, totally five slanting edges Here, three slanting edges visible based on the given conditions. Three slanting edges visible to the observer. Remaining two slanting edges invisible. If it is visible, you have to represent that by continuous line. If it is invisible slanting edges, that parameter has to be represented by dashed lines. So here, two slanting edges are coinciding. When I say see from here, OC, OD, these two slanting edges are coinciding and getting only one line instead of two slanting edges. So both of the slanting edges are coinciding. But in the front view, I can able to see only one slanting edge, that is OC. So that is written here. The D dash, that is written inside the bracket because the OD slanting edge is coinciding with the OC slanting edges. In specific, OD slanting edge is invisible during the front view. So this is step number one. In step number one, I have got true shape of bottom base as well as a true axis length in the front view. Now step two. Step two is the actual final front and top view based on the given condition. Here the given condition is that one of the triangular face that is resting on horizontal plane. So here you see the top view versus the top view. One of the triangular face means I am taking this OCD. This OCD triangular face will be a line. Is look visible as a line in the front view. So what we have to do, we have to tilt the first step front view in such a way that this OCD line comes on axis line. Sorry, that reference line, XY line. So they have to tilt this first step front view in such a way that this OCD triangular face line comes in on XY line. In such a way, we have to tilt the first step front view. Then we have to reproduce the remaining parameters without changing its shape and size. So if it is tilted, we will be getting the second step front view. This is the second step front view after tilting the first step front view based on the given conditions. Then we have to draw a vertical projection line from second step front view, horizontal projection line from first step top view. Then we have to mark the intersecting points. After marking 5 base, corner, and one apex intersecting parameters, we have to connect all the base sides and the slanting edges. Finally, we will be getting final top view based on the given conditions. During the given conditions, if we take top view, we will be getting a reduced shape. At the same time, we can able to see only three slanting edges during the top view. Three slanting edges and five bottom base sides. Everything visible during the top view. But one of the triangular face is resting. Uh, that face containing two of the slanting edges will be invisible during the top view. So that is represented by dashed lines.